Hello everyone, my name is Jack. Maybe I should get the webcam in here. Oh, fuck me. I'll figure out the webcam later. The important thing is, my name is Jack Jimenez, and recently, I've been learning a little bit about C++ and OpenGL. I've been reading this book online that just pretty much goes over the entire thing for you. So I wanted to talk to you about some of the cool things that I've stumbled upon that I think I want to share with you, Mr. Audience. So, the thing that kind of catapulted this idea for the video is how cool it was to implement a physics engine. And I'm not talking about, getting down and dirty, pulling out my fucking worker hat and trucker hat and wrench and making it, actually doing collision detection. I just stole it. There's a thing called physics, which is an NVIDIA property, I think. Please don't sue me. I don't think they sue you. I'm tripping. They don't sue you. This is something for anyone. Hobbyists, alcoholics, anonymous. You can just use an implementation of physics and add that to your project. Essentially, you create these imaginary scenes with imaginary parts of the scene. So if you want to make a floor that is a rigid floor that nothing can go through, you can kind of just do that. You can make a rigid static floor, and physics gets you a function that creates an infinitely spanning floor at a certain point on your axis, for whichever axis you choose. So I chose the y-axis. It would just basically create an imaginary floor that goes the entire way, and I added it to my scene and it works. The most important thing is that these are all not printable or not sort of viewable. They work, and if you output their global position variables into the console, you'll see that, oh, this ball is right here, this cube is right here, my cock is right here, and you can kind of deduce what's going on. But the important thing is that if you want to actually see these things in actions, this is where the trick comes in. When I was learning to draw stuff, I was kind of positioning everything on my own. I picked a position and I kind of changed it. For the camera, I just changed the camera position, and I was able to just move around the scene. But when you position other objects, you just position them in the scene. There's nothing really that dictates where they should be, where they should stop. And that changes with a physics engine. The physics engine has limitations and stops you from entering certain areas. So what you can do is create these models, these shapes, floors. You can load a model from a model loader, from any 3D object, .obj, .whatever. You can put that shit into your project. Sorry, stroke. And you can print it. But instead of just printing it willy-nilly, you can get the position of that object in the physics scene that we talked about. So essentially, every single position that that imaginary object is going through can be extracted and put on the rendered object. So it looks like that object is, experiencing physics, but really it's just following the actual thing that it's experiencing physics. So let me just show you. This is an example application that I created with OpenGL and implementing the physics engine. And I stole a little house. I took a little house from the internet, as we internet people do, and just a nice little brown house. As you clearly saw, the ground is a static, infinitely spanning physics object. This shit goes on till the end of time. But if I took out the drawing method for this kind of wooden floor, as you can see, so all we have to do is take out the drawing code for the floor. So the floor no longer will be drawn with the texture, the wood texture that we assigned to it, but it doesn't really matter. the physics part of it still exists. So there's still a floor that captures this sphere that I've made. And the house still stands and the ball still stands. Nothing will get past this imaginary barrier, because we said so in our physics scene. And that same mentality works for this ball. This ball is a dynamic object, which means that it's going to be moving around and needs to, you know, account for mass and inertia and stuff. So this object is just a sphere I created from the physics implementation that I then went into Blender and just made a normal ass white sphere. Try to put some fucking emoji on it, but you know me, that shit didn't work. But it's just a sphere, and then I loaded that rendered object from Blender, took the position of that sphere, and then also got the rotation because it's a fucking sphere, and I put it on the object. There's also some player control, so when I press the keyboard and stuff, it actually goes places. But this is essentially it. It's just okay, well. There you can see one of the first of the problems. I don't even know what's going on. Methinks that because it's going so fast, it doesn't have enough time to render each position of the ball. So it'll just clip through it because it doesn't render the point where it should be like, oh, we're not clipping through the ball. Like if I go slow enough, boom, we're good. Boom, we're good. This works pretty much as intentional. But yeah, it's a work in progress. Oh, fuck me. What I also added, and maybe you'd be noticing, is there is a grapple point, a grapple hook, sort of. It just pulls you in. It just picks a point, and it just pulls you into that point. Travel balls and shit. That's not intended, but I mean, it's just how it is for now. That's a cool little hole trick. Yeah, it's just a really cool thing I wanted to showcase. You can also see me going inside this chimney. Oh yeah, I'm in that fucking chimney. Yeah, that's pretty much it. All right, goodbye.